So, hello guys, today I am here trying to derive the equations of motions by algebraic and calculus method. So, without wasting more time, we start the derivations. Let's start the derivations. Firstly, we will derive the equation by calculus because the calculus is more critical, more tough than algebraic method. Algebraic method is nothing. There is only 2 or 3 lines. So firstly, we will do the calculus method, then after we will do the algebraic method. So first we start for the first equation of motion, which is v equals to u plus at. So first we start and so first we will write the a is equal acceleration equals to velocity upon time. We all know there is nothing. Only we will do differentiation of acceleration. Acceleration equals to dv upon dt. Nothing, sorry, differentiation of it is integration. We will only do integration of acceleration and derive dv upon dt. So acceleration equals to dv upon dt. dt a is equals to dv. Here a is constant. So a becomes here and we put the sign of integration and dt equals to here is also dv and we put the limits here and we will put the limits. The limit is initial time 0 or final time t and here is initial velocity, sorry, final velocity upon initial velocity. Final upon the initial velocity. After we will do some, then we the acceleration is constant, then we put the limits like a t minus 0 equals to v minus u bracket, there is a t equals to v minus u, so v is equals to u plus at. First equation of motion derived, I can show you. See the equation of motion first. I will add the picture of this equation of motion. Then we go ahead with the second equation of motion. We start with divided into 2 parts and then start with second equation of motion, which is v equals to dx upon dt. We also know velocity equals to displacement upon the time. So sorry for the delay. V is equals to dx upon time. Velocity equals to displacement upon time. There we put the integration and start, and dx is dt, put dt to cross multiply. So dt dot v is equals to dx. Then applying integration, on dt वेलोसिटी v की जगह हम लोग in the place of v we put the equation of motion, equation of first motion, which is equals to u plus at. So dt dot u plus at equals to dx पे इंटीग्रेशन का साइन, तो इंटीग्रेशन ऑफ dt dot u plus dt dot at equals to dx. v u is constant, so u को बाहर निकाल लेंगे, प्लस a is also constant है, तो a को आ जाएगा, तो dt dot t equals to इधर dx रहेगा, क्योंकि x is not a constant. Then we are applying the limits. dt के ऊपर लिमिट लगेगी t की 0 की, so here is ut plus एक्सप्लेनेशन इधर t पे लिमिट लगेगी, इधर लिमिट लगेगी t स्क्वायर अपॉन में 2 एंड t 0 इक्वल्स टू x पे लिमिट लगेगी फाइनल की इनिशियल की, तो आ जाएगा x फाइनल माइनस x इनिशियल, ut प्लस t स्क्वायर अपॉन में 2 माइनस 0 स्क्वायर अपॉन में 2 इक्वल्स टू x फाइनल माइनस x इनिशियल and ut plus t square upon में 2 t square upon में 2 equals to that x initial, we know the displacement equals to final position minus initial position, so x final minus x initial is equals to delta s, delta s ut plus there is a is also, so ut plus half at square equals to s, hence derived, I will add these pictures in this video. You will see these equations. And we go ahead with the third equation of motion, the derivation with the calculus method. Firstly, I will erase it. So third equation of motion we will derive. Third equation of motion, which is A equals to v dot dv upon में dt. So we know acceleration equals to displacement upon में time. The integration लगाएंगे v. So v dot dv upon में so we also come on the back topic. So we derive the third equation of motion with the method of calculus. So third equation of motion, we firstly derive acceleration equals to v dot dv upon dx. So we start the equation of motion with the derivation dx the cross multiply dx is go here, so a dot dx equals to v dot dv dx is integration of v dot dx, so is equals to integration of v dot dv. इंटीग्रेशन इधर लगेगा यहाँ is constant, so ये बाहर dx equals to v, यहाँ v dot dv, यहाँ डिवाइड कर रहेंगे फाइनल की, इनिशियल की, फाइनल की, फाइनल वेलोसिटी नीचे लगेगी इनिशियल वेलोसिटी, एक ब्रैकेट में x फाइनल माइनस x इनिशियल, वी ऑल आर नो, इज इक्वल्स टू v स्क्वायर अपॉन 2 v and u इज इक्वल्स टू a डेल्टा s आ जाएगा इक्वल्स टू v स्क्वायर माइनस 2 माइनस u स्क्वायर अपॉन 2. So that is as equals to v square upon 2 minus u square upon 2. To when we take the LCM of this, it will become v square minus u square. दो को इधर भेज देंगे 2as हो जाएगा, यहाँ से हट जाएगा. So hence derived. This is the third equation of motion, which is 2as equals to v square minus u square. I will also post this picture on my channel, so can you don't able to see this very clearly, so can you see the picture of this? We start with the derivation. We start with the derivations of equation of motion by algebraic method. So I think algebraic method is the very simplest method in my point of view. So we will start without wasting the time. So first equation motion, we know acceleration is equals to final velocity minus initial velocity upon the time. So nothing but only we can write the acceleration equals to final velocity minus initial velocity upon the time. So when we do the cross multiplying, a t equals to v minus u, and v minus u को इधर भेजेंगे तो v is equals to u plus at. उसका derived हो गया. There are only 3 steps, hence derived. There are only 3 steps. For 3 steps, I think there is only 2 steps. So first equation is derived. Then we go for the second equation of motion. So the second equation of motion के लिए हम लोग simply कुछ नहीं formula write करेंगे. We know about the velocity is equals to displacement upon the time, but I will add new formula of this. Displacement upon time equals to displacement upon time equals to velocity equals to displacement upon the time, and velocity equals to final velocity plus initial velocity upon next 2. There are 2 formulas. So then we start, and I show the new formula which I tell you. And this is the fourth equation of motion in 11th class, which is added. I think it is comes from these 3 equations. These are not the very new derivation like velocity equals to displacement upon the time, and velocity equals to final velocity plus initial velocity upon the t. This is the equation first, this is the equation second. And when we equating both equations, as upon t equals to v plus u upon 2. We do the cross multiply of this. Comes here. 2s equals to t bracket में u plus v. Can we write in the place of velocity equals to can we write this in the place of final velocity v equals to u plus at? We know the first equation of motion is equals to u plus at. Can we write in the position of v is u plus at? Then we write t bracket में u plus at. there is 2u plus 2s equals to 2 bracket में 2u plus 18, 2s equals to 2ut plus 80 square, 2ut plus 80 square. We take this to send this to here. So s equals to 2ut plus 80 square upon with 2. We know 2 is the part of both of the things, like 2ut is the or 2ut 2 is the part of 2ut and 2 is the also part of 80 square. So we can write 2ut upon with 2 plus 80 square upon with 2. 2 से 2 कटा, so s equals to ut plus, इसको हाफ लिख सकते हैं हाफ 80 square. This is the second equation of motion. Hence derived. There is nothing. And I will show the third equation of motion. I will also share this picture on my channel. So you are not able to see this. I will again repeat. You will not able to see this. So can you see this picture on my channel? So firstly, there is no new things. We write v is equals to s upon t as the previous derivation, and v is equals to u plus v upon a 2. Equating both equations like previous. This is equation first. This is equation second. And this is equation first. Equating both as upon t equals to v plus u upon 2. You are derivating as equals to u plus v upon 2. तो इधर आया. We know that previous equations v is equals to u plus 80, so t is equals to v minus u upon a. So as equals to u plus v upon 2 and then v minus u upon a as equals to v square minus u square upon a as equals to v square minus u square upon 2a. So 2a as equals to v square minus u square. So derived is equals to v square minus u square. I will post this on also on my channel. Can you see this on the and not able to see this? Here you can also see this in my channel. So this is enough for the today, and we will meet on the next session. This is the most important derivations of the motion in a straight line, which is most important, I think. Only these 6 derivations which I do in this video only important in the second chapter, and some basic questions are there of the motion under gravity also. So there is no more tough concepts. So let me meet in the next video. Thank you.